Welcome, everyone. This is Jyoti Dodia. Welcome to today's session in the PowerVog webinar series. Today, I'm really pleased to have Kris Whitney with us to talk about this very exciting new function called Db2 Mirror for I. And without further ado, I'm going to hand over to Kris. He can introduce himself and then take us through this exciting function. Thank you.
Welcome. Good morning, good afternoon, evening. Looks like we have a great representation across the globe, and I see some familiar faces on the chat, so that's great to talk to you guys today. Today we're going to talk about Db2 Mirror. I had the pleasure of starting this project and working on it from the beginning, and kind of discussing that a little bit before the call. It was actually probably 4 to 4.5 years ago, and what really came about from this was customer feedback, and we really try in IBMI to listen to our customers, and sometimes it's very challenging to solve what customers are asking for. But we're hearing pain points on business continuity problems and things that they wanted to see the IBMI platform to kind of take it to that next level of availability. So we came up with some ideas on how to improve business continuity problems for IBMI customers. And we'll take you through that today to kind of explain how that works. Now, as I go through these slides, I don't just want to plow through the charts, so please ask questions in the chat window, and Jody will interrupt me and we can have more of a discussion, because the real key is to educate you and to kind of get your questions answered on how the product works and positioned. So what we're trying to do, IBMI Db2 Mirror, is an infrastructure enablement for continuous availability or high availability. This is going to provide solutions to some of those problems that we have today when you have OS downtime for maintenance, whether it's planned maintenance or unplanned maintenance, those type of things. What we're trying to do is take our availability story to a near RPO and RTO of 0. That's the goal, and this is the product that gets us very near to that goal. At a high level, this is going to be a new product that requires Power 8. We'll kind of go through the hardware requirements and why we need Power 8. And it's also a prerequisite that's IBMI 7.4. So that's going to be our base technology that the new product for Db2 Mirror 5770 DBM is built on top of. Kind of positioning Db2 Mirror into the realm of high availability, we can start over on the right-hand side, which is your active inactive type solutions for DR, essentially. So basically, you're typically replicating your entire VM, so typically from the storage perspective, and the recovery point for this in the event of a crash or even a planned switch is an IPL. And so it takes time to switch over to the other side, bring up the system, reconfigure it for whatever it needs to do on the other site, and then start your applications up. So it's a very good DR solution from a simplistic standpoint. It has some challenges when you're talking about the time to recover and the data loss depending on the distance and those type of things. The middle column is active-passive type clustering technologies. So if we go to IBMI specific technologies, this is where Power HA would be. So we have 2 nodes or 2 LPARs, and they're both up and running, but then we're switching an independent ASP between them. And so in order to do that switch, you have to vary off your independent ASP. You have to take down your application. You have to switch that independent ASP over, vary it on, and start your application up. So that switch over, even if that independent ASP can switch very, very fast, and we've gotten that down to a relatively short time, you still have to start up your applications again, and so that whole infrastructure switch could take more time. The left-hand column is the active-active clustering, and this is where we're trying to position Db2 Mirror. And this is where both sides of the nodes, both LPARs, are up and running, and they can actively access that database. So this is in the same realm of function that solutions in Oracle RAC on AX and Linux have, Db2 PureScale, and Z SysFlex, where you can have your applications up and running on both sides. So let's kind of dive into how Db2 Mirror is going to work. So there's I'll call them nodes, and nodes are the same thing as LPARs in this terminology. We just chose to use nodes in a lot of our documentation. And a node can be an individual server. It can be on two different servers or on the same server. So it's really an LPAR. That's the unit of work. The key thing is that they're two separate LPARs. We're not taking two LPARs and kind of merging them into one instance. No, we're keeping those two instances. Those two LPARs are wholly identical. And then as the name kind of suggests, we're mirroring between the two LPARs. Then there's certain objects that will support mirroring, and there's certain ones that don't. And this is where we build that infrastructure that you can then build your application stack and then build your data center solution on how you want to get to an active-active solution or a faster switchover type solution, those type of things. So what's going to happen is when your application inserts a record, in this case Fred in 24, that is going to get propagated over to the other side in a synchronous manner. So the key here is it's synchronous, meaning if it doesn't happen, we know what did not make it to the other side. And so we have a very consistent view of the world. We don't have an asynchronous nature where it's kind of ambiguous between the two sides. And so in the event of a failure, we know which side to go to, and we know the state of the data on that side. The key point in being able to do synchronous replication is a high-speed, low-latency networking technology. We chose to implement this on top of what's called RoCE. RoCE stands for RDMA over Converged Ethernet, and so it's a type of technology that's typically seen in high-performance computing environments where they're clustering lots and lots of nodes together to get that low-latency characteristic. The database transactions do not have to be an independent ASP. So that's what's one of the reasons this is slightly different than PowerHA is there's no requirement for your database objects to be an independent ASP. It could be in SysSpace, or we do support independent ASP, so you can do either or. So from a database perspective, we support both the native record level access that a lot of applications are still written in today, or we support SQL. So you have your choice. So lots of applications can sit on top of the database and be replicated at the database layer just kind of naturally. When you replicate your database, you also get kind of the attributes that go along with those database files, so the row permissions, the column maskings, temporal tables, constraints, partition tables, those type of things get replicated between the two systems.
Kris, there is a question, if I may interrupt. So the question is, so Oracle already has this type of PF feature. What should be the pitch point for us in this case?
So the pitch point is, typically speaking, to migrate from an IBM application stack to an Oracle stack isn't straightforward. And so instead of migrating, we kind of gave you an option to stay on the platform if you have the requirement for this zero downtime, this clustered type database. We did implement this very differently than Oracle. Oracle implemented a shared disk strategy. We implemented a mirrored strategy. So Oracle, both databases are going to the same disks, and then you're kind of locking it and doing that. We're two separate databases, and so what's going to happen is over time, those LPARs can diverge as far as like PTF levels. And because they're completely separate systems, we have some advantages, I believe, in how we're going to be able to support different levels on each side. So there's going to be, you get to stay on your IBM. You get the continued integration of the whole stack is within the platform. And you're going to have this characteristic of an entire partition versus a shared database where there's some interesting problems they have to solve in Oracle. But Oracle has some advantages. We're only going to be two nodes because it's a mirror technology where Oracle has multi-node support, so you can share that same database with more than two nodes.
Okay, thank you. Another question was how people can get hold of the slide deck, and I will be posting the slide deck along with the replay later on, hopefully later today. So as I mentioned before, it is being recorded. Last question at the moment is what's the maximum distance between the two nodes since it is synchronous replication?
So what we're going to support at GA time, which is June 21st, is a relatively short distance. So it's a data center solution. The max cable that we qualify is 100 meters. You can take that cable and plug it port to port, so you don't actually need a switch, and so your max distance in that case would be 100 meters. We do support switches, so if you put a switch in the middle, you could effectively get double that to get 200 meters. But we do position this, at least initially, as a data center solution within probably the same type of machine room, depending on how far or how big your machine room is. And then you build a DR solution on top of Db2 Mirror to get offsite. Because it's synchronous, we can't really change the latency of the speed of light. So as we go on in time with the product, we hope to extend that, but it's really going to be dependent on the customer and if they can tolerate the additional latency incurred by going any amount of distance. So in the future, I never see this going more than what you would consider like a metro mirror distance, which you can argue what that is. 50 kilometers, maybe up to 80 kilometers would be the absolute max that this product probably could ever handle at a synchronous technology.
Okay. Lots more questions are coming through. Are you going to be covering the hardware elements?
Yes.
The rookie.
Yes,
yeah,
I'll cover the adapters.
Okay, let's wait till then, and I'll take more questions a bit later on. So carry on, Kris.
Okay. So besides the database specific type objects, in order to your application to kind of sit into this active-active environment, there's some other objects within the operating system that we've included in our mirroring product. So some of those objects are user profiles, authority, ownership, security. Those are kind of a unique set where you're not going to have any choice on if you mirror those type of attributes or objects. So every user profile you create, change, delete, those type of operations gets automatically synchronously mirrored between the two systems. With one exception is QSec offer, so that's unique on each one. But besides that, every other user profile gets replicated. And that's because if you create a physical file on one side, we want the same owner. On the other side, we want the same attributes on the other. But as far as most of these other objects, those are going to be selectable with rules that you create on whether they're going to be replicated or not. So you can select which libraries and which physical files and database things I talked about in the previous slide, and you can select some of these. So things like programs and service programs. You may choose to replicate those, or you may choose to use some other software distribution technology to push your change management to each side. So on a program or service program, that gets replicated actually when you save it or close it, and then it gets restored to the other side. Data areas, those work how you'd expect. You can select a data area, and then that data area will get replicated. Data queues, you'll notice, has a DDL only kind of nomenclature next to it. DDL is data definition language. So this is kind of the container, the attributes of the data queue, not actually what gets queued to the data queue. So if you write something to the data queue, that is not going to get replicated to the other side. If you change an attribute on the data queue, that does. The thought process behind this is typically right now applications aren't quite ready for active-active, so they couldn't really handle a data queue receiving something from the other node and kind of understand, where it came from. Over time, that might change. System values, environment variables, libraries, these are all kind of selectable. So some of the system values will be allowed to be changed, others won't. Those type of things. So you kind of have to sit back and say, does it make sense for the system value to be different on it, or do I want to always keep it in sync? There's things like the CSIDs and time zones. Those things are always mirrored, and you can't unselect them. So one of the key things to take away is, so journals are on this list, but the actual replication between the two systems is not using remote journaling. It's not a logical replication type solution that a lot of vendors out there are using, but we do replicate optionally the journal if you want between each one, but it's just the journal, once again the container. It's not the receiver entries that go into the journal that get replicated. Effectively, both journals will end up with very similar journal receivers, because as we replicate the database action between the two nodes, that would generate a very similar journal entry on each one. The difference would be potentially the sequence numbers would be different on each side, depending on what else has gone on in the journal. We also support replicating spool files. Those are a little different in that it's more asynchronous, meaning we're not going to support writing to the same spool file from both sides, but when you close a spool file, it will get replicated to the other side. So it's kind of an asynchronous process in that respect. Job queues are very similar to data queues in that the job queue itself is replicated, but the job schedule entries that go into the job queue are not. If you want those replicated to each side, there's techniques on how to get those moved over to the other side, and then you'd have to take an action to reschedule those. So the third kind of major data type that we support is IFS, and IFS is built on top of PowerHA. It kind of extends where PowerHA leaves off. So if you look at how IFS would work in just a pure traditional PowerHA environment, you have your independent ASP, you have your file system in the independent ASP. That file system would only be accessible on the node that has the independent ASP varied on. On the other node, you would not be able to mount that file system and access those files. So what Db2 Mirror has done is extend that to be able to access the node from both sides, access the IFS file system. So if the IFS file system is varied on node 1 in this case, on node 2, you could mount that file system and read and write from node 2. In the event of a failure or a plan switch where PowerHA would switch the independent ASP between node 1 and node 2, Db2 Mirror would actually reverse that client-server file system relationship. And so from an application's perspective, it would not understand that an actual independent ASP switch has occurred underneath the covers. And so the file system would do what we call a mutation. So it mutates, and then the clients would just have essentially a long file access, and then it would take off from the point it was at without a failure. But in order to do this, to kind of switch that independent ASP under the covers, that's where the PowerHA requirement comes in. If you have a requirement to be able to mount the same file system on both sides. Some application topologies don't require that, where the file system is actually going to be unique to each node, and so they would not have to implement this type of remote file system type of technology.
Perhaps I can interrupt with a couple more questions, Kris. There are a couple of questions about the hardware and the licensing, which I know you're covering later, so I'll leave those. There's a question about whether this solution also supports live partition mobility.
So initially, and we'll get into a little bit more on the networking aspect of it. The networking aspect, initially is going to assign it directly to the partition. And on IBM I, we currently have a limitation when you do live partition mobility that you can't have any native adapters or native SRV adapters. Removing that restriction is something that we're looking at for the future. So hopefully down the road a little bit, we'll be able to support live partition mobility in a Db2 Mirror configuration. Typically, right now, because of the sensitivity to latency, we don't support this over any type of generic Ethernet, like virtual Ethernet or VNIC. And so that's kind of where we're in this catch where we have physical hardware, LPMs requiring the virtual hardware, and we need to figure out how to bridge the gap between the two.
Thank you. There's a sort of another question which I think is related to what you've just said, which is, do I need the network link for mirroring, or is it also possible with storage mirroring like MetroMirror with two DS8000s?
So the way we were implementing Db2 Mirrors at the OS level, so it's integrated through the whole stack, through the OS. There's a BOS option, there's an LPP, and it's integrated within our database layer, and then we're replicating at the OS to OS layer, which has an advantage of over storage replication where it's a bit-by-bit copy. We can have different actual physical bits in each OS, but logically speaking, between the two databases, those are 100% identical. So your rows and columns are all the same between the two. By doing it up here, it gives us more flexibility to have differences and to accommodate differences, where when you do it at the hardware level, you can't have any differences because the hardware level doesn't understand the database objects individually. They're just looking at sectors. So yes, you have to do it up at the OS level, and the hardware layer is really going to be left for the DR solution.
Okay. And another question, is it mandatory to keep the user profiles and authorities same on both the nodes?
Yes, so and it is mandatory, and it's something that we hard enforce, so there's no option not to keep them the same. There's some interesting cases where they can diverge when mirroring is, we call it suspended, and so we're actually not in a mirrored state. They do diverge, and then when we connect up, we resync those back together. There's things like GIDs, UIDs, all those have to be the same on both sides in order to successfully mirror the objects.
Okay. There's a question about what happens if there's a crash. So when we say active replication with Db2 Mirror, how are the transactions going to take into effect when the production system is holding a file for commitment control and then there's a system crash?
Yeah, so that's a great question, and we'll go through a couple of crash scenarios, but the one thing that I do want to address right now is when you're in commitment control between the two nodes, we'll have an open commit block. The other side will see those transactions as they happen go over to the other side. If we crash in the middle of it, it effectively will roll back on the one that crashes. The one that continues to run, we go into what's called a tracking mode, and so even though you have an open commit, it will not roll back, and so you'll continue with your application on the one that's up and running, and eventually you'll probably hit a commitment boundary, it'll commit, but we're still tracking that. When the other node comes up and we reconnect, we will resync back from the beginning of that commit. So the other side rolled back because it crashed, and on the IPL it implicitly rolls back. When it gets up, we'll resync from the beginning of the commitment boundary and catch up to the other system.
Okay. And then the last thing on here is, does it mean that we cannot do hot if we're using a lot of IFS for online applications?
If you're using a lot of IFS, you just have to implement kind of where I was talking about, where you have the second node remotely mounts the file system, and it goes over that high-speed Rocky network to the system that has the independent ASP buried on. Mm-hmm. There is a performance difference because it's a remote file system in this case, but if you're used to our Net Server 400 and some of our other, we have several remote file system technologies. This one is significantly faster performer than any technology we've done before. So even though it's not native IFS performance, it's still very, very good. And so that's the one thing that I would kind of caution is if you absolutely are pushing the performance boundary on today's IFS, doing that on the remote side, you're going to see some degradation on some operations versus the native one today.
Okay, thank you. I'll let you carry on. There are some more, but we'll take them as we go through. Thanks.
Okay. So I kind of want to discuss a little bit about use cases of Db2 Mirror. And so kind of the most straightforward one is if you already kind of have separated out your transaction or your application from the database, Db2 Mirror kind of just slides in. So in this picture, it's a web client. It does not have to be a web client. It could be any type of application layer that sits above IBMI that clients are coming in. And if you want to implement an active-active or even something that's going to switch very quickly between the two, you have to have some type of load balance or some type of connection technology to direct traffic to your database. And so there's a couple ways that this is commonly done in the industry already today. And this is the same actually problem that you probably have solved if you have PowerHA today or logical replication on how you direct your clients between the two nodes within your availability solution. The only difference here is we could direct people to both nodes simultaneously in a hot type environment. So a couple technologies. One would be a hardware type technology where you use like an F5 load balancer and you're spraying the IPs between the two. That's a very easy way to get traffic going to both nodes. Another way would be to use a JDBC connection from the application layer. And in fact, from IBMI's perspective, we have the JT Open product for our JDBC implementation, and we've enhanced that to support connection pooling. What connection pooling does would have an IP address for each of the nodes, and you put that into the pool. You define your primary. The primary would go to, let's just say, node 1. If node 1 goes down, the JDBC layer would automatically retry that transaction on node 2. So that's kind of an easy way to kind of utilize Db2 Mirror. The most simplistic might be just when one node goes down, the IP address for that node switches to the other node, and then people connect in through that other IP address. So even if your application stack or infrastructure isn't quite set up to do that today, maybe it's more traditional where the entire database middleware UI is all sitting on a partition within IBMI. There's still ways to take advantage of Db2 Mirror. So kind of the easiest way is you run on one node for that transaction type processing, those traditional green screen things. But maybe you can take out or isolate the querying process, the business intelligence and analytics, and put that on node 2. And that would reduce the CPU and disk reads on node 1 and then move it to a second node and kind of distribute the workload between the two. The key advantage here is that since this is synchronous replication, you're effectively getting the same database view as you would have if it was all running on node 1. And so you're not waiting for journals to be replayed on the other side. You're seeing that instantaneous same view. The other key thing is since this isn't an independent ASP type replication technology, even if we're using independent ASPs, the independent ASPs are varied on both sides. You can access the data. So that's kind of why it's a little different than what we can do with PowerHA today. When you're kind of evaluating what applications can take advantage of this, there's some key things to think about. This is a database replication technology, and so there's tools and stuff that probably have no need to be aware of the two nodes and the two nodes in the cluster. There's the scheduling type things. Those might not necessarily need to go across the two nodes. Your backup solution is going to be a little different, but the backup solution runs independently on both sides. We did implement, as far as the backup solution goes, if you're using the BRMS and our traditional save restore type interfaces where we can save just the non-replicated data. So that would be something that libraries that you chose not to replicate, or system libraries that we are not allowing you to replicate. Those are unique on each system, so you would save the non-replicated ones, and you can save the replicated data, and you can kind of differentiate the two because you don't necessarily want to save the replicated data twice. So you kind of have some flexibility in how the backups are going to work here. So another use case to kind of solve some of the rolling upgrade scenarios, that those pain points that cause system outages throughout the year. I'm just going to kind of walk through how that might work. And so we have 2 nodes. We're in active-active, and I'm going to assume that you can switch your users or your application transactions between the 2 nodes with some type of technology. And so whether we're running active-active or active-passive from an application's perspective, it doesn't really matter, but you have to be able to switch them between the 2 for this use case to kind of work. And so the first thing we're going to do is we're going to say we got to install maintenance, install PTFs on the secondary node. So we're going to suspend mirroring. And so what's suspending mirroring? So I'm showing a picture of the GUI, and we're going to suspend here. It's going to look like this. So the primary partition is the one that is going to stay up and tracking. And this is the first time I've introduced the concept of primary and secondary in an active-active runtime condition. You can go to either node and they're equivalent. That it's being mirrored, both ways, so it doesn't really matter which you're going. But from a failure system scenario or a planned scenario, the primary one is the one that's going to stay up and track. So that's where we want to continue running production. So all your users should be running on the primary at this point. The secondary one is the one we're going to take down, and we're going to install the PTS, do server maintenance, whatever we want that might need an outage. During this time, those objects that were being replicated are in a block state, so they are not accepting changes to those database files. There's some other objects like user profiles that are allowed to change, because when you install new software, install PTFs, they can create user profiles, they can change user profiles, they can do a bunch of those security type settings. Those are actually being tracked on the secondary system, but the database files, the actual data that we care about when you talk about like your bank account, that's being blocked from changes. Some of the ancillary objects, those are the ones that we're allowing some changes to happen. And then after that, and this is kind of showing that tracking list. And so while we're in that condition, we're tracking those changes on that primary side, and then we're installing our PTS on the other side. So in this example, the spool files have changed. There's some physical files that are changing. And a key point out here, for every physical file that we have a database I/O change to, you're only going to see that physical file in this list one time. So since we're not using like a journaling technology to kind of track, this list is not going to grow forever. It's a very fixed, bounded list, and so we're very efficient in how we track changes within the database itself. So after that maintenance is done, you IPL potentially, it's still going to come up in that block state because this was a planned maintenance. And when you're ready to go, we're going to resume Db2 mirroring. And what that's going to do is it's going to go to that tracking list, and it's going to start pushing those changes across. So the top bar is kind of an indication that we're not started yet, and we have at this point in time 946 operations. And then we started resuming, and it ended up being 1,000 operations that we have to resync. And then we get a little progress bar. And then there's a bunch of drill down stuff, so you can get more detail on exactly what type of objects and how long each type of objects is taking to synchronize to the other side. All this time we're running on that primary side, pushing it to the other side, so that application hasn't gone down on that primary side. Then we'll be back in sync, and we'll be able to start up the applications. We'll move people over to that secondary system, and then we'll do what we'll call a role swap to the primary, and then we'll start the whole process over, and we'll do the other node. The other node will be the secondary, and we'll repeat the process. So that's when I talk about a rolling upgrade. Those are the type of scenarios that we hope to be able to handle going far into the future with, TR levels and QM packages and things that always require an IPL between the two systems. So I'll pause there I'm sure there's questions, and all that.
Yes, Kris, thank you. So there are some questions about the GUI, and I know that you've shown some screenshots and you're going to be showing some more. So there is one to manage it. Let's see. They would like to know how SQL Index Advisor and SQL Optimizer will work in the scenario.
Yeah, so those are unique to each system, and so those won't get replicated, and they behave slightly different depending on your workload. And so the you'll probably want to, if you're running just on one side, your other side won't have necessarily the same plan cache and all those type of objects kind of hot there from both sides. So you might want to run a query, an important query, to kind of refresh it on the secondary side if you're only running it from one side. Currently, there's no way to move those between systems, and so you'll want to kind of manage that depending on how you're using it. If you're running active-active, though, it will probably be the behavior you want, where each one is being updated individually on each side. If you're only pushing users to one side at a time, that's where there could be some issues with those type of objects.
Okay. Will both systems have their RDB entry the same, i.e. the database name?
Yes, the RDB entries are the same on both nodes. They have, but there's more. The name is the same. There's some unique attributes, I think, with IP addresses and stuff like that beyond. But
okay. Somebody's asking if there's an implementation guide available now, and I've posted a link to the Knowledge Center, which does have a link further on to the guide as well. So that's in the chat window. When mirroring is suspended, does the secondary reject JDBC connections, or is it up to us to make sure nothing is running on the secondary?
so I can speak to the IBMI JDBC implementation, and when it goes suspended, we will recognize that and switch. Now, there's lots of JDBC implementations in the industry, and there's even more than JDT Open that runs on IBMI. And so I can't really speak to all the behaviors out there. What will happen, though, is on the block side, they will get exceptions if they try and update a mirrored object. And typically speaking, that exception would cause a JDBC driver to switch over. Our JDT Open one actually can detect it faster and switch over on the state change itself and not have to wait until it gets a failure.
Okay, thank you. On the OS upgrade, could you do one at a time, or must you do both at the same, both nodes?
So our intention is, our intention is going to be you can do one at a time. So since we're just going out, we'll see how this goes. But the design is to, let's just say the first thing that's going to happen is potentially a QM or a TR comes out in the near future. And so you upgrade one of the nodes to that new TR level, and then you can resync, and you can be in an active mirroring on different TR levels between the two nodes. So you don't have to take a full outage to do that, and that's why we can do that rolling upgrade. There might be some situations where the compatibility needs to be the same, where you'd have to get both sides up, but our design point is to try and avoid that as much as possible to give you that continual availability characteristic.
Okay. There's a couple more questions about licensing, but I know you're going to cover that in a while. So if we haven't answered those questions by then, we'll take them then. Will file indexing for SQL get into effect? If I run indexing on one file on the primary system, how is it going to work for the secondary system?
So an index is an independent object. So if you and then you have a choice whether you're going to mirror that index between the two systems. And so if it's mirrored and you create an index on node 1, it would get mirrored to node 2. If it's a not mirrored index, it would be unique to only node 1 in this case, and so it would not even exist on node 2. So you could have an application that's using that index on node 1, just independently, and it goes down, and if it updates a physical file that is actually being mirrored, those changes will get replicated to the other node. So you kind of have a choice on indexes whether they're mirrored or not.
Okay. Another question is, the documentation says the data on both nodes is available for production use, but could this possibly cause a conflict when updating the same record from both the sides?
So we have to support being able to try and update both sides. And so logically speaking, if you had two applications on the same LPAR, they can try and access the same row and update the same row at the same time. And so what happens on a single node LPAR would be there would be a lock conflict. So one of the applications would win, the other would sit there and wait. A very similar thing happens in Db2 Mirror, where you have to get a row lock to update that row, and so one of the nodes will win. It will grab the lock. The other one will get a lock wait or a lock timeout, saying I'm trying to, but the other guy has it. The way you manage that's very similar to a single system. The messages are slightly different in that there's a message that says there was a lock failure due to the other node holding that lock. And so we keep our data integrity by using locks, and that's the other reason why we have to be synchronous. If you're asynchronous, you can't guarantee a locking protocol, and so you could end up with writing data on each side to the same row. In Db2 Mirror, since we're synchronous and have all this locking, you can't do that.
Okay. How long can the target LPAR be down? How many transactions can the primary hold, and where are the transactions held?
The primary can track, in theory, indefinitely. We don't grow our space because we're not based on a journaling type technology. So within the database itself, there's a mechanism that we track it, and so you're not using any additional storage. You could end up changing every single row on every single table on the system. So in theory, you could be down forever. So the real crux of the problem is what happens, how long is it going to take to get back into a synchronized active-active mirroring state. So if you change every single row and every single table, it could just take a lot longer to resync that. We have some ways that we kind of speed that up under the covers. Instead of resyncing row by row, we may choose to do a save restore of that object just to get it back in sync faster. And when we do save restore, we're not going out to tape or anything. We're actually doing a save restore over that RDMA network. And so it's much faster than you might think of using save restore, depending on your network bandwidth there. The other thing is, and I'll briefly touch on it, is you could, depending on how you set up your system to manage it, you could reclone, we call it, and a reclone could use hardware assist, in this case meaning a flash copy or a metro mirror, to kind of get back into a active-active state faster. Now, of course, if you choose to use flash copy or a metro mirror, you might lose the divergence between the two systems. So if you're using the two systems for different purposes and installed different applications, you would lose that differences, because obviously a flash copy is a bit-by-bit copy of one or the other nodes.
Okay. There's quite a few questions rolling in. I'll just take a couple more and then we'll take others towards the end. Are there already ISVs who have their applications certified for using Db2 Mirror?
There are ISVs that are currently working on it. There is one ISV that I'm aware of that announced their support for it, and that would SyncSort announce their support for their Mimics product to be a DR solution on top of Db2 Mirror. The other ones, it's a very challenging thing, because some applications just naturally work and there's little to no work, and so we're not necessarily doing an IBM certification. So to be quite honest, we're not tracking that. We are working with lots of ISVs to answer their questions and see what they want to do to exploit Db2 Mirror to its fullest.
Mm-hmm. And there's two more questions which I think it's worth taking now, which is, do the two sides of the the primary and the secondary nodes, must they be the same hardware type? And I imagine that they're asking power 9, power 8, that sort of thing.
No, since this is an LPAR to LPAR communication, there's nothing dependent on the generation of power, and in the future we think that's going to be a great use case to potentially upgrade in a rolling fashion where you take one node out, one server out, and roll in the next server and then resync your data. So that's going to be a great use case. There's some, and I'll address it a little bit later, I guess, there's some limitations on which adapters go in which generation of hardware, but even there we can talk between them. So there's no limitations between the hardware levels.
Great, thank you. And then what is the estimated processor overhead of using Db2 Mirror?
That's a great question, a very challenging question. And I have a very performance-y answer. It will depend on your application, and that's a very honest answer. There's things that contribute to more processor overhead and more, I'll just say, general overhead in the application. So I like to look at performance from a more holistic perspective of, what's going to happen when I submit something to IBMI and then I get a response. So what's that entire application response time impact? Because now we have the latency involved to send that traffic over to the other node and get the synchronous response. And so there's lots of aspects of performance into that besides just processing overhead. So from an application level, I've seen things of a 10% overhead up to, twice to a 200% overhead. And what really depends is a couple of factors. The biggest factor is the percentage of updates to the database. So within that transaction stack, how many inserts, updates, and deletes do you do to your database? And then you kind of have to weigh that those are going to be the ones that have to go to the other side that get penalized. If it's a mostly read workload, Db2 Mirror is fantastic because reads we don't have to send over to the other side to get a response on those type of things. But we generally recommend, so if your partition, I'll just use the example of is 10 cores for your partition. Your second partition, the starting point is probably identical, at least 10 cores. It's not always the processing that's going to be the overhead, it's going to be that networking, but there does take some processing on that secondary to receive those transactions and to apply them. That's why we start out at the same. There is potential on that secondary if you're not actually pushing new workload to that secondary one, it's just receiving workload from the first one, you can reduce the CPU on the second one slightly to compensate. So.
Okay. Thank you very much. I'll leave it there for the time being, and we'll take more questions towards later on.
Okay. So I think I already addressed these two. We're different than PowerHA. We don't use independent ASPs. We support them. So you can access your data on both nodes. And logical replication, we're different because we don't use journal receivers. Now, the key here is this is a data center solution, and you still need a DR strategy, usually. And so to get off-site, you'd probably still use logical replication, or you would use the physical hardware replication full system or PowerHA to kind of get off-site as a DR strategy. And so this is just a picture representing that. Well, maybe you have 2 servers at your production, and maybe it's only 1 server at the DR site, because these are really partitions. We don't really know the difference. You can set up Db2 Mirror or not at the DR site. That's kind of up to you. Logical replication, similarly, you can do the same thing. Typically speaking, with hardware replication, you do have 4 nodes. With logical replication, you could have only 3 in this type of topology. I'll discuss that a little bit more towards the end on DR solutions if we have time. So there were some questions about the GUI. So all the pictures I've been showing are pictures of the actual GUI. The GUI runs on IBMI using 100% IBMI technology. and we don't support any other types of platforms to run the GUI. There's a couple different ways you can approach the GUI itself. One is you can go to one of the LPARs within the Db2 Mirror pair itself. There's a couple limitations on what you can do there as far as the setup of Db2 Mirror. So for the setup of Db2 Mirror, you actually have to run on a different IBMI partition to do that initial setup or that reclone. When we run outside the Db2 Mirror pair, we kind of name that the third node in the pair. It's not actually participating in the data replication, it's just participating in the GUI management of it. This actual panel is showing that where we're managing 3 Db2 Mirror pairs and kind of showing a status of that. And so you would choose which one you want to manage, you click on it, and it would drill down into the more specific Db2 Mirror pair you want to manage. So the second part of managing Db2 Mirror are SQL Services. Over the last, I'll say, 5 years, especially the last 2 years, we've been very heavily invested in providing SQL Services into the system management type realm. And so you can do a lot of things now with SQL Services just to manage your system. From the get-go, we chose to use SQL Services as our primary way to manage Db2 Mirror from a command line type perspective or a programmatic way to do scripting. So there's lots and lots of ways you can manage Db2 Mirror directly through SQL Services that kind of are very nice when you're manipulating large data sets, so you can drill down in with SQL. Not everyone's a big SQL fan or into, doing their own thing with SQL, so we try to make this as easy as possible. So with our ACS product, we are going to ship some examples of all these commands that you can just click on and execute, and they'll manage Db2 Mirror that way with more of that click way. If there's things you want to do that are a little different than our examples, that's easy to cut and paste. Those type of things. Now, what you'll notice here is I'm not showing any panels with green screen commands or green screen panels themselves. And that's by design. We chose not to do that. With our flexibility with SQL Services and our GUI, we think we have most of the primary ways to manage this. And I'll just throw a plug out there. If you really require commands and don't want to create them yourself off these SQL services, Lab Services is more than happy to provide you a toolkit. They've done that for a long time on our products like PowerHA to customize it to your needs. Otherwise, there's a lot of flexibility straight from the UI, the GUI, and the services themselves. I actually just went through the performance kind of spiel. Just keep in mind you can load balance a little bit to separate and get traffic on both sides. If you insert, update, delete, they could, worst case, there's certain ones that could be 2 to 3 times. That doesn't necessarily mean your application is that worse off. You have to look at the percentage that is being replicated between the two. Setup, obviously, you start with one node, you want to get into a pair, so there's some guided setups. But the first thing you have to do is you have to go out, you have to define that LPAR, you have to define the storage. You don't have to install the partition. We're going to take care of that as part of our setup procedures. On GA at day one, we require external storage, and that's primarily for our setup because essentially at day one we need an exact clone. And then after we have that exact clone, the systems can diverge, but the things that we need to track are identical between the systems. So like the user profiles, the GIDs, the UIDs are all the same, where there's some challenges if you start from 2 separately installed partitions to get them the same. So that's why we require external storage, is to get that initial clone between the 2 systems. After you've created your shell partition, you go to the HMC, you input your storage, you input your partition name and stuff, and the HMC information, and then we can drive from there. We'll drive the complete process of all the cloning if you have DS8000 storage or if you have Spectrum virtualized storage. If you have other types of storage or different types of configuration of that storage, then there's a manual process, and so basically the wizard will pause at certain steps in the process, and then you go out and you do the storage. Like if you have EMC storage, you go out and do the RDF functions, and then you come back and say, yep, my clone is done, and then we'll continue the setup process from there. So here's the hardware chart that a lot of questions on. So there's actually 4 adapters that we support, and what I did not update is on Power 8, there's only 1 adapter. So the 3rd adapter, the PCI Gen 3 100 gig adapter, that's the only adapter that's qualified on Power 8 in general. The other 3, and including that one, are all supported on Power 9. The big difference between Power 8 and Power 9 is whether or not we support SRV. So Power 9 has the capability to take that adapter and using SRV to assign logical ports to separate partitions. So the same adapter can go to separate partitions without the VIOS. On Power 8, there's no SRV functionality in the firmware on Power 8 for Rocky adapters. So that's the big difference, is you get more adapter types on Power 9 than Power 8, and you get SRV. The other key things with these 100 gig adapters, they have to go into the system KEC units. They can't go into the expansion drawers. So you kind of have to watch your card placement and architecture when you're trying to place these adapters. The 10 gig adapters, those are the ones that can go in drawers. So the other question that we get a lot is, well, how many ports do I need for Db2 Mirror? Of course, that depends too, but from most of our evidence in the lab and our testing so far is to drive 100 gig worth of bandwidth, let alone on one port, let alone multiple ports, because these are 2-port cards, is extremely difficult. So unless you have very large partitions, a couple 100 gig ports are very effective at that. The 10 gig is where we can probably saturate those. So, you know, the cost difference I don't think is a huge difference between the 100 gig and the 10 gig, so I'd maybe recommend using the 100 gig and kind of oversizing your bandwidth. The other thing to point out is you don't have to have a 100 gig switch infrastructure necessarily to do this. You can cable them back to back. So hopefully that, you know, won't inhibit 100 gig adoption. I think those are very good cards for Db2 Mirror, because we just don't have to worry as much about where we have too much bandwidth to overdrive the cards.
So there's a couple of questions that were related to the hardware adapters. One of them is, if you have multiple LPARs, do you need multiple Rocky adapters in each LPAR, or do you need them in each LPAR that need mirroring? I believe they can be shared, but...
so on Power 8, you do need the adapters assigned straight to each LPAR. On Power 9, you can share the adapter between LPARs using SRV.
Okay. I think that's it on the hardware side for now. Thank you.
So from a hardware redundancy perspective, we do have a redundancy model. You can have up to 16 links in this network redundancy group, we call it. This is an IBMI technology where it's a software redundancy. So at our networking layer on each side, we're creating the redundancy. This is very similar to a link aggregation or ether channel type implementation, but that's done more at the hardware level and the switch level. And so what this does is it allows us to have a very flexible redundancy model and be able to separate different types of traffic. And so the different types of traffic that we have in Db2 Mirror are database, IFS, system objects. The big one on system objects are spool files, so if you replicate a lot of spool files. But this gives you the flexibility to isolate different links for different types of traffic and have different priorities and different failovers. By default, all links can failover for all types of traffic. And so you have everything running on one link, but we could peel this off, and then if one link fails, we just fail back onto the other links that are left in the redundancy group. So it's a very flexible way to manage your redundancy models within IBMI itself, instead of having to go to a switch and do it at that level. There's some, I guess, I'll pause there. That's kind of going out of the hardware realm. Do we have any other hardware questions?
I don't believe so. Oh, there is one. If the partitions must be equal regarding the number of disks and sizes when you start, because you said you have to clone, how do you handle it when you have to add more disks to the partitions, I guess, on one side?
So typically speaking, so there's nothing going to enforce that they stay the same on each side. So you're now managing each side independent from a disk management perspective. Now, if you ever wanted to reutilize cloning to kind of re-establish the baseline, reset up, at that point in time, you'd have to get yourself back into a state where they're the same sizes and the same number. And so potentially a best practice might be to, if you add disks to one side, add them to the other side at the same time for the same size. Hopefully you never have to utilize the reclone as kind of the last resort to kind of get yourself back into mirroring. And so it's kind of a hard best practice to suggest, because I hope we're not using this much in the field, to be quite honest. But you kind of have that choice up front to make if I'm going to have that insurance policy, if I need to reflash copy, or if I'm just going to utilize the Db2 Mirror itself and always resync through Db2 Mirror. So.
Okay.
All right.
And one more that has just cropped up, which I think the answer is no, but DB Mirror must work with the Rocky card. Did we also support DBM over TCP LAN?
No, Db2 Mirror is not going to be supported over TCP IP directly. We actually, it'll look a little bit funny because we do create TCP IP connections between the two systems, but that's only to establish our Rocky, and then once we have established our Rocky connections, then we're 100% Rocky. TCP IP has some characteristics that make it challenging to support Db2 Mirror as far as performance and as far as reliability. The Rocky provides us better qualities on both aspects.
And then another related question to Rocky is, how does Rocky adapter work with VIOS?
The Rocky adapter can't be assigned to the VIOS, so you have to assign that straight to the partition. All your other I/O can go through the VIOS, so you can still get your disk, you can still get your partition TCP/IP connectivity through virtual Ethernet or VNIC or anything like that. It's just that the Db2 Mirror Rocky traffic has to be directly assigned to the partition.
Okay, that's it for now. Thanks.
Okay. So I wanted to talk a little bit about how you manage Db2 Mirror for my rules configuration. So at the beginning of time when you're setting things up, you have a choice to make on how your rules are going to work within Db2 Mirror. And so you have this default inclusion state concept, and so by specifying exclude, that means all the rules that you create are going to add to the system to be mirrored. So by default, nothing is mirrored. You create a rule, it adds to what's going to be mirrored. If it's the default inclusion state of include, that means your entire system, all the eligible objects for Db2 Mirror are going to be replicated. And if you create one of these objects, by default, it will be replicated. And so it's kind of the nothing or the everything kind of choice you have to make up front. And that has implications on how you manage the system going forward. And so the default I chose was exclude, because I think that's actually probably the safer way, even though a lot of customers have told me they'll choose the ease of management, basically, because if someone creates a new library, they want that to be replicated. So with that in mind, you can create these rules. These rules are for objects and tells us what to mirror. The object or the library does not have to be in existence when you create the rule. They can be what we call phantom rules for objects that might come into existence at some future time. You can specify it on a library level, saying I want library XYZ and I want certain object types, or you can say all object types. You can drill down on your rule all the way down to the object name. At the object name level, that's fully qualified, and we today don't support wildcarding on the object name itself. And so you can kind of wildcard on the data types, and you can wildcard on I want everything in this library, but the actual name starting with A, we currently don't do that. So you create this rule for the object that you want. You pick include or exclude, and that's probably going to depend on how you set up your rule. But if you set up, I wanted all objects in library Fred, and then you can create another rule that says, but I don't want data queue of Jenny to be replicated. So you can exclude Jenny from the replication. So you can have a hierarchy of rules to kind of manage what exactly you want replicated. So the other aspect of this is, well, I have all these rules. How do they look when my system is going to be mirrored? And so we have this inspect button, and the inspect goes out and applies the rules to your current system, and it shows you what's included in replication and what's not included in replication. If you have a question on why one object is replicated and another isn't, you can show the applied rules, and it kind of shows the hierarchy that got applied to that object. And then you can go back and manage your rules to kind of manipulate getting that into replication. So there are some rules that we ship with the product itself called system defined, and these are rules that you cannot change, and these are mostly for system objects that if you would replicate them, you would damage your two nodes. So we keep you out of the weeds and in this respect. So these are mostly the Q libraries. These are product libraries. So if you use our product install tools, our programs, and then that would drive down and create these system-defined rules so that product libraries themselves don't get replicated. There's some exceptions here. QGPL is a strange one in that the library itself isn't replicated, and most of the objects aren't replicated in QGPL, but people put things like OutQs in QGPL. So OutQs, you can select the OutQ to be replicated out of QGPL. So they'll have some, like a partial lock on things like that. You can also create a group of rules, and so you might have a very complex rule system like it kind of showed before, where a library, but you excluded certain things in the library, but you really don't want replication to go until you got everything excluded. And so you can create a pending group, and that's that group of rules, that hierarchy that you might want to. So you set a name on that, and then you can inspect what that set of rules will do to your system. And then when you're happy with that set of rules, you can apply the pending group, and then replication would start after that apply. So on just a single rule, you have the option of whether you want to delay it and set it to a pending, or you can immediately apply it, or you can create a group, and then that would be kind of a delayed pending apply group. So any questions on rules?
There was a question about Q star, but I think you answered that already. There's another question saying star program is supported, but not star command, CMD?
Right. Commands aren't, yeah. You would create the command independently on each side.
Okay. I think that's it on the mirror side.
Okay. So I already kind of talked about the primary and secondary, and I kind of want to just kind of review what happens in failure scenarios. And so we kind of talked about how one side goes tracked, the other side goes blocked, but there's some nuances here. So we configure things to talk to the HMC, and then we have this additional quorum, and that's just another node. Typically it'd be on your DR site, but it's a node outside of the two being mirrored, and it kind of keeps track of state, so we can remember kind of the history of what's going on. So when we get into really crazy failure scenarios where you're IPLing one side and then the side that remained up, maybe it goes down and IPLs, we have to find someone that understands what's going on, because we can't trust our partner because he might not be up. And so we don't know if in the middle of our IPL he took over as the primary and started tracking, because what we're trying to avoid is changing the same database objects on both sides and then having a conflict, and we don't know which is the right data. So we try to really avoid those conditions. And so by using the HMC and by using this additional IBMI cluster node, we can keep track of kind of what's going on within the ecosystem. And so if the secondary fails at IPLs, MSDs, ghost restricted state, all those, the primary is just going to keep tracking. When the secondary comes up, it will resume and go back to being actively mirrored. If the primary is the one that crashes in MSDs, this is where the secondary has to make a decision. He has to decide, do I stay the secondary and block all the replicated objects, or do I take over as a primary and begin tracking? And so we ask the HMC and we ask our additional node, hey, what's the state of that primary? And if we get it back an answer that says, oh, they crashed, they took an MSD, then we'll auto take over as that primary, and we'll continue to accept database changes on that secondary node. If the network fails between them, this is another similar case where they're both up and running. So we really want one to stay up and track, and we want the other one to go into a blocked. The primary has been designated by the user as the one that they want us to favor as the one that stays up and tracked. The secondary is the one that has to do the processing. In this case, you would ask the HMC, and the HMC would say, nope, that primary is still up and running and looks healthy from our perspective. And so that secondary would not auto take over as the primary and track. He would remain in a block state. So there's another concept as part of that kind of if a system goes down, it crashes, it comes back up. There's the concept of resume automatically. So what that means is we'll kick off the resynchronization process automatically. And so that's on by default. If you turn that off, that just means the user has to go in and click the resume button to start the resynchronization process. There's an attribute on that resynchronization process of the parallelism that we'll use, so how many jobs and threads that we'll use. So if you have option 26 on your system, you can change the degree of parallelism for resynchronization so you can use multiple threads. That's good and bad. So if you want to get the two systems back in sync as fast as possible, that will use more CPU to drive that resync. If you're running production and you want the resynchronization to kind of just sit in the background and be done when it's done, maybe you don't want to increase the parallelism degree. So there's some thoughts behind that when you do the resynchronization process. The third property in this list is the spool time replication. So spool files, once again, are more asynchronous. So once it closes, then they get pushed over with a save restore to the other side. But you can delay that, and so that gives a chance to bundle those up into a bigger save file effectively, and it gets moved over in a bigger chunk, which is more efficient from a CPU and a networking perspective than smaller chunks of data. So you can set that up between 1 second and 1 hour, just depending on your toleration of if you go down in that window, you would potentially lose some of your spool files. Or you wouldn't necessarily lose them because when the system came back, they would be there, but you would not have access to them on that secondary node. So from a managing and monitoring, there's lots of ways to do this, but we've given some exit points. So when you change your state, for instance, you're running and you go to a track state, that means you took over, or you are the primary, took over as the primary, but you're continuing to run. Maybe you want to send something out to direct people to tell them, hey, I'm the primary, I'm the one that's accepting all transactions at this point. And so there's a programmatic way that you could do that within your infrastructure to tell a different system that, hey, I'm the one that's open for business, and the other node stops sending stuff to the other node. So depending on your technology, there's different ways to implement the switching of the whole infrastructure outside of IBMI to which node you want to direct it to. There's lots of serviceability things. A lot of these are internal to us when we want logs and stuff for the product, but the one I'll kind of call out is the compare tool. And the compare tool gives you the ability to verify that the two objects on each side are identical. You can compare the attributes of the object itself, the data within the object, or you can compare both. This is on a object level, a library level, or even the entire system level. So you kind of have granularity on what you're comparing and how big you're comparing the whole system or not. But this is all submitted to batch, so it's asynchronous. And then you sit here, because it could take, depending on how many objects on your system, it could take quite a while. So in my case, between a minute and maybe 10 minutes, depending on how many I had in here. But the key thing to pull out is on this column says 0. That just means I had 0 miscompares. If there was a miscompare on like a physical file, I could drill down into that, and it would show the differences between the two physical files on which row was out of sync. There's alerting. So Db2 Mirror alerts get sent to QSysOper and some other job logs and such. On the GUI, there's a monitor there that sits there and gives you this little count of how many there. You can click on that, pull it up, look at them, and mark it as red, and so that would decrease that count. Just kind of lets you do as much management from the GUI as possible without going to multiple interfaces is kind of the design point. It's not 100% there. There's still things that if really complex debug, you might have to go to a different interface to gather more stuff, but most of it's right within the GUI. Independent ASPs, kind of talked about that. They're optional. For DB2 data, they're required for IFS. You actually you separate the two because the IFS is switchable between the two DB2 Mirror nodes. If you have database independent ASPs, those are not switchable between the two DB2 Mirror nodes. Those would be switchable between the production DB2 Mirror and the DR DB2 Mirror. This is trying to show the GUI again. So this has multiple database and IFS independent ASPs, and they're down at the bottom. You click on them. They have their own individual replication rules and their own individual tracking lists and those type of things. And so the management of an independent ASP is very similar to the whole system itself if you're just in sys-space. And so the look and feel is very similar there too. Here's some operations you can take on a independent ASP. You can resume it, remove it, vary it on, vary it off. This is a database one. IFS is slightly different because, once again, I can switch that between the two DB2 Mirror nodes, and so we have a switchover capability if you want to manually switch over that. In a planned maintenance scenario where you're doing maintenance on the secondary, you might want to preemptively switch your IFS over to the primary node if it's currently on the secondary node for some reason, or when you're doing that role swap, you might want to switch that independent ASP at that point in time. So you don't have to go to a Power HA interface to do that for IFS. You can do it straight here. You can also vary it on and vary it off. So some basic independent ASP management from this GUI. DR, I talked through a lot of this. Key points, though, I want to make on this slide is with a Power HA or hardware replication, you'd probably want 4 nodes because you want each of the nodes in DB2 Mirror to replicate their view of their hardware because they're 2 independent partitions down to the DR site. With hardware replication, we can't, if a source of one replication gets cut off, so let's just say node 1 fails, I can't take node 2 and take his view of his LPAR and his disks and replicate to the DR site because it's a bit-by-bit copy and the two LPARs are unique. And so really we only have one DR switch now, and that's the node 2 to node 1 switch. I could go now to my DR site. I can configure DB2 Mirror at the DR site. I could be running in that mode, or those could be 2 standalone partitions that are just going to run standalone until we switch back to our production and get ourselves back into a DB2 Mirror configuration. Logical replication, you're going to have to check with your vendor on how they're going to implement DB2 Mirror, but logical replication has the capability to do a 3-node topology because they're doing remote journaling, and they could potentially pick up from where they left off on the remote journal. They have some invention to do when they do that because, like I said before, that the remote journals aren't identical as far as a sequence number, so they have to understand we provided a technology that you could match up remote journals even though the sequence number isn't the same, and they can switch and take over. But some customers want DB2 Mirror on their DR site because if they run on their DR site, they want to be the same as the production, and so you could do the 4-node configuration with logical replication also. How that's implemented, you really need to check with your logical replication vendor to see if they can do things like that with switching the source and keeping the same target, or if they need 2 different links to go down, like the hardware replication. I'll pause briefly because I know there's lots of questions on software requirements and licensing, but
I think just carry on, Kris, and we'll take any remaining questions at the end.
Okay. So here's the list of required software. The key ones to point out is option 26. That's a chargeable one, and that gets you the parallelism on resync. But the other ones that are new, brand new for DB2 Mirror are BOSS option 48 and the DB2 Mirror product itself. And the chargeable piece of Db2 Mirror is this option 1 on the 5770 dBm, and I'll walk through how that's charged in a second. The other aspect to Db2 Mirror and our setup and our cloning process is we use some open source to do that. So there's some Python that's required and some Cloud Init RPM packages that have to be installed to do that setup. If you're running your Db2 Mirror GUI on a third node and managing other nodes, you don't need as much software. And the key thing here is you don't need that option 1, and that's where the price tag on Db2 Mirror is. And so to run the GUI, it's free. To actually do the mirroring, that's where you need the licensing. So how does the licensing work? The pricing is $20,000 per core, and there's no tiering, so this is any size machine. The licensing is necessary since this is an active solution, and there's currently no way to block traffic on the secondary. You have to license both as if they were active systems. The option 48 is required, but it automatically is included in the 5770 dBm orders at no additional charge. We have a 70-day grace period for the DBM product, and option 48. So it's the standard try and buy as you would with the IBM base OS license. This is per core, so this follows the same strategy as the IBM OS and PowerHA, where it's a per core, per serial number type licensing entity. The 2 production nodes in your Db2 Mirror environment don't qualify as a CBU offering, but if you have a DR solution and you could potentially have 2 Db2 Mirror nodes in your DR, those are the ones that would qualify as the CBU units for a DR type environment. So we're full processor charge metric today, so subcapacity licensing and options aren't there. So workload capping is going to be supported as far as a functional thing to isolate Db2 Mirror into its own group of processors, memory pools, subsystems, those type of things, if you want to manage your environment in that fashion, but there's no subcapacity licensing associated with that workload group. And the link will be here on the T's and C's and the gory detail on licensing terms. So with that, there's 2 more slides, and I just want to put a plug in. Lab Services does have an offering for this. I named it, it's not an official name, but I call it the Kickstarter Workshop. So it's basically a way to get education to dive into applications, to dive into infrastructure topics, and then it's actually an on-site in Rochester type engagement where we have hardware set up in our benchmark center where you can do some benchmarking with your application to kind of understand the potential impact it could have to an application. Lab Services, of course, always will do custom stuff, but this is kind of more the turnkey offering. You can use your PowerCare credits and stuff with this type of offering if you so choose. And then I think the link is already out there, but our Knowledge Center is out there. It's going to continue to grow. We have substantial content out there. It's probably over, I think last I saw was over 400 pages. And this whole book will continue to grow for the next few months as we get more and more detail and more knowledge from our early programs and early customers that adopt this and such as that. We've tried to take a very different approach with writing the Knowledge Center in that we tried to take more of a red book approach and have a little bit more use case and kind of a linear step through the process mode to this. And for the most part, I think we've succeeded. So the PDF definitely flows like that. The individual links are good to jump straight to a topic. So take a look at that. The intro and the setup and planning and a lot of those topics are out there in some substantial form. So with that, I think that's my last slide. So any further questions?
Thank you so much, Kris. I'll just mention to everyone that I am planning some more sessions, probably from July onwards now, as I'm away for some of the time in June, so I don't think we'll have a session in June, but I will post information about that in the usual manner on the wiki page and email you details of those sessions as soon as they are set up. There are lots of questions that have been coming in, so if I could just take some of those. Bear with me while I work out which ones we have not yet answered. Okay. I think there was a question about load balancing between two systems in active mode, but I think you covered that already. There was a question about GUI and console, which you've covered. GBC, yeah. I'm just trying to check ones that we have not yet covered. Okay. There's a question about file, reorg, and purge, whether the same applies, but I'm not sure which question this was talking about. It is related to a previous question.
Hello, Jyoti. This is Shrikant. My previous question was regarding the indexing, and Kris said that if we add that particular file for indexing, and it will get copied via DB Mirror. So in the same way, like if I am doing a purge or reorganization in one file on OS 400, will that going to take effect on the target system, or still we need to add that to take into effect?
So if it's on a mirrored object, like a mirrored file, it does take effect. So the reorg will take effect. And so there's some, once the DDL, we call them DDL internally, operations, so reorg, alter table, those type of things. Anything that gets a lock and changes the data will occur on both sides.
Thank you.
Okay. Thank you. How does Db2 Mirror behave with application upgrades? For example, if file structure changes, does it simply take the new file structure and replicate to the second system?
Yeah, so the application upgrades themselves on the surface could happen independent of each other unless it changes your data model. And so if you do some type of alter table, that alter table will occur on both sides. So it'll get a lock on both sides. And so if you add a column or something, that will occur on both sides. And so you have to take care that now that that new column is on the other side, that and the data model has changed, that the application on the target can also handle that new change, whatever that might be. And so application upgrades are still a little fuzzy depending on what the data model is and the data model types of changes.
Are there system task names that can be tracked in terms of CPU usage for this?
Yeah, so most of the unique work for, so you have to decide where you are on the server. So if you're on the source side where the transaction's initiating from, that will happen within the job itself that's executing. And within that job, it'll send over that replication to the target system. On the target system, there's going to be job names that are associated with that source job. So it's kind of a one-to-one correlation, and they have unique names. On the target side, those are the ones you can put into its own subsystem and its own workload capping group and those type of things. The source side, it's a little harder to tease out the replication piece because it's happening in line with the job.
Okay. There was a question about a particular picture on a slide where you were showing primary site and secondary site. And on the primary site, there were two nodes, but one storage. So they're just asking for clarification. Do we need separate storage for each node on one site?
You have the complete flexibility, so you can share a storage box on a site, or you can isolate it into its own storage box. The difference being is how you set up. So if you're sharing the same storage box, we can exploit flash copy to do that setup, so it's a little faster. If they're two separate storage boxes, we have to set up a mirroring between it, whether it's Metro Mirror, Global Mirror, between those two, and then to get that initial setup clone between the two boxes.
Okay, thank you. You answered. Will a start ASP balance affect the mirror?
It'll affect it indirectly. So there's nothing. So a start ASP balance is unique to one system because it's under the database layer. It's actually in the we call it the storage management layer that sits below database, and so we can shift around our segments and change which disks units they're on and all that independent on the two systems. What indirectly might influence it, though, is when you're doing that, you're slowing down your disk access on one system. And so because of the synchronous replication, if that synchronous replication had to do a disk write on the target node for some reason, then that disk write might be slowed down slightly because of that. And so the other system would kind of see that indirectly.
There's a question on the reorg side. If you were to run a reorg on the fly on one side or both sides, are you able to run a reorg on the fly on one side or both sides at the same time when DBM is active?
No, because I believe there's locking that will get in the way, so you'll be hung up on both sides until that's finished.
Okay. There was a question on the rules. Can the same object be part of two groups if we set to include? Not quite sure.
So an object could be inherently part of two rules, meaning you could say I want all objects in my library, and so that object would be part of that all object rule or the system rule. But then you could create another rule that says this type is excluded, and so there's a precedence of if we fully qualify it down to the name, that will take precedence over the object type, and the object type takes precedence over the whole library, and so forth. So there's a hierarchy of rules, so it could be affected by multiple rules.
Okay. And this is talking about the attributes compare. Are security definitions included in the attributes compare?
Sorry, I got interrupted. Are the attributes?
Are the security definitions included in attributes compare?
Yes, and actually, just a nuance. So the security attributes in general would be included in the object, but then there's other authority lists and such that are also in the realm of security attributes. Those can also get compared, but how you compare all those, you would click on QSys. User profiles, for instance, don't actually reside in a library, so when you pick QSys, you get the user profiles, you get the authority list, you get a bunch of things that aren't library type objects.
Okay. And if you are defining a compare on a library and you're replicating 5 objects only from one library, then will it compare only those 5 objects or the entire library?
So you can select, either individual objects or the library. It will just compare the ones that are replicated. So it does look at that as an attribute in the compare, whether it's replicated or not.
Okay. Is it possible to have tracking over different versions of a database file? For example, if we want to take a node down to install an application upgrade that includes a new database column, can Mirror use default column values for the tracking node when new rows are inserted? I think you kind of answered a similar one before.
So can we track a different format? Is that?
Yeah. So
okay. You're right. So if you change the format, okay, yeah. That doesn't work yet. So the data model in itself has to be the same. So if you take one down and you change it, depending on which system's tracking and which one's blocked, on the block system, you're not going to be able to change the data model or do an alter table. On the one that's tracking, you can change the data model there, but then when you bring the system back up, it's going to resync the data model so they're back in the same. And so there's no case today where you're running with two different formats.
Mm-hmm. Okay, this was a question that you'd already answered, so let's carry on. Is there a way to sync replication policy entries between a production Db2 Mirror pair to a separate Db2 Mirror pair of nodes?
So today how that's going to work is it's kind of a manual sync. You can export the rules and you can import the rules on the other side. Today there's no automatic way to do it. Those are concepts that we're kind of looking at. The whole kind of design point for the most part for Db2 Mirror is that we're not knowledgeable of other Db2 Mirror pairs, and then there's DR products that sit on top of us that replicate between two Db2 Mirror pairs. And so whether that function is actually going to be within Db2 Mirror itself or whether it gets included in like a PowerHA product or a logical replication product is still kind of on the table, because we're not trying to manage DR. I'm trying to draw a very fine line between what's continuous availability or HA on a data center and what's the DR management's responsibility.
Mm-hmm. And I'll take one final question, and then we'll have to carry on and answer those questions at another time, or maybe take a note of all the questions and create a document with Q&A. Do you recommend that a web application WAS load balance across both nodes, or will it cause too much object database locks to be practical? They have several web apps, and they're wondering if it would be better to have some apps connect to one node and the others to the second node.
That's going to be very challenging to answer in a generic because WAS is, I think, a very applicable technology to use in this solution. It really depends if both sides are going to access the same rows on the tables, and it's hard to answer if that's going to be true or not until you set it up. But in theory, if you don't have a problem today with WAS users getting row lock conflicts on a single system, in theory, the Db2 Mirror shouldn't be any worse. So you kind of got to monitor that and see if that's going to be a problem, and then maybe you do just direct it to one side at a time.
Okay. Well, thank you so much, Kris. We'll stay on. I'll stop the recording, and then we'll stay on for a couple of minutes, if that's all right. Thank you so much for covering this session today. There's been loads of questions, so a very interactive session, and you've managed to answer all the questions that were asked thus far. So thank you very much for doing this. And thanks so much for your time for attending, everyone. I will stop the recording there.